Bright Duty. Every student matters.
Hello students, my name is Sanjay Jain. Today we will study about an important theorem related to triangles, and we will make use of our knowledge of quadrilaterals while proving that theorem, the midpoint theorem. So we will talk about the midpoint theorem today. Let us talk about this theorem. The line segment joining the midpoints of two sides of a triangle is parallel to the third side. So for example, if we have got this triangle here, let us say this is triangle ABC, and let it be the midpoint of AB, and let this be midpoint of AC. If I join these two midpoints, this line segment DE, line segment joining the midpoints of two sides, is parallel to the third side. So we will show that line segment DE is parallel to side BC, right? So D is a midpoint of AB, so I will represent it by marking these two segments with two bars, and let me mark it by one bar. So it says that this segment is equal to this segment because D is the midpoint of line segment AB. Similarly, AE is equal to EC, right? This much is given. Now I need to show that this line here is parallel to BC. For that, I want you to do a little construction here. I want you to extend DE such that, let us extend it up to F, okay, such that DE is equal to EF, right? So we are extending the segment DE up to point F such that this DE is equal to EF. Now if I join F with C, right, look at these two triangles now. This segment is equal to this segment here because of the construction I have done, right? This segment is equal to this segment because it is given, and this angle here is equal to this angle because these angles are vertically opposite angles, right? Now look at these two triangles. By side angle side congruence rule, what can I say about these two triangles? That triangle AED is congruent to triangle CEF. Let me verify the correspondence also. AE is equal to CE, yes. DE is equal to EF. Yes, this is also true. And the angle in this angle E, in this also angle E, so angle E. So this correspondence is right. Now based on this congruence, I can say that corresponding parts of congruent triangles are equal, right? So FC here is equal to AD. AD is equal to FC by CPCT, right? This is one result that I have got here. Now if FC is equal to AD, what can you say about this DB? Will it be equal to FC? Yes. Hence DB is also equal to FC. Why? Because D being the midpoint, D is midpoint of AB, hence AD is equal to DB, right? AD is equal to DB, hence DB is equal to FC, right? Now, number one thing. Second thing, that this angle here is equal to this angle. If this is theta, this will also be theta, because these are corresponding angles, corresponding in terms of corresponding parts of congruent triangles, right? So this is opposite this segment and this angle is opposite this segment. These two segments are equal, so the angles opposite to these are corresponding parts of congruent triangles, right? And if these angles are equal, now these angles are alternate interior angles, hence this side will be parallel to this side here, right? So these angles are equal. Angle ADF is equal to angle EFC. I have represented these angles by theta. Hence, lines AB and FC, AB and FC are parallel because these angles are, because the mentioned angles are alternate interior angles, right? So by now I have proved two things for you, that this segment here, let me change the color so that it can be easily identified by you. I have proved two things for you right till now, that this segment here, segment DB, is equal to this segment FC. Another thing that I have shown you, that this line AB is parallel to FC, hence this line DB will also be parallel to FC, right? DB is just a part of AB, so it is also parallel to FC. Now from the knowledge of parallelograms, we know that if DB is equal to FC and DB is parallel to FC, what can I say about this quadrilateral here? That it will be a parallelogram. That DFCB, now what should you write? DB is equal to FC, DB is equal to FC, DB is parallel to FC, hence DFCB is a parallelogram. DFCB is a parallelogram, right? Once you know this, that this is a parallelogram, now you can say that what do you want to show? DE is parallel to FC. So yes, you can say that this line here is parallel to this line, hence DE is parallel to BC. Okay, once you know this is a parallelogram, it is very easy for you to find out that DE is parallel to BC. Another thing that you can notice here is that it is a parallelogram, right? And EF is equal to DE. EF is equal to DE by construction, and it is a parallelogram, so I can say DF is equal to BC. Opposite sides of a parallelogram are equal, right? Now these are halves of side DF. DE is half of side DF. So what can I say about DE? That DE is half of DF, or I can say it is half of BC, right? So what I have shown you here is that DE is parallel to BC and DE is half of BC, right? And how did I do that? By proving that these two triangles are congruent. How did I do that? I took EF equal to DE. This was the construction that I did, and then these two triangles became congruent, and by corresponding parts of congruent triangles I proved that these two this is equal to this, hence it is equal to this, and these angles are alternate interior angles and equal because of CPCT. So this line is parallel to this line, hence DFCB became a parallelogram and the results followed, right? So now I'll prove this theorem. The line drawn through midpoint of one side of a triangle parallel to another side bisects the third side. This is also the converse of the theorem that we just proved. So if I have got a triangle, let us say I have got this triangle ABC, okay, and of side AB I take midpoint as D. So AD will be equal to DB. AD is equal to DB. Another thing that is given is I need to draw a line parallel to the third side. So I am drawing parallel to BC here. So now if I take this point DE, so DE is parallel to BC. Okay, so these two things are given, and based on these two things I need to prove, or I need to see that AE is equal to EC. AE is equal to EC, right? So this will be the converse of the theorem that we just proved. Now if I extend DE construction, I need to extend DE and let it meet with a line passing through C and parallel to AB. So I draw a line through C parallel to AB, right, and extend DE to meet this line here at F, right. So this line here is parallel to this line, right. This DE is already given as parallel to BC. What can you say about now? What can you say about quadrilateral DBCF? I am saying the quadrilateral DBCF is a parallelogram. Why? Because opposite sides are parallel. This side is parallel to this side. This is already given, and this side is parallel to this side by construction. So I can say that this quadrilateral is a parallelogram. Now it will meet all the properties of a parallelogram. So I can say DB is equal to FC. Number one, DB is already equal to AD. By the properties of parallelogram, I can say it is also equal to FC. Okay, and now this angle is equal to this angle. Let me take this angle as theta. So this will also be theta. These are vertically opposite angles, right? Now this is a parallelogram. I have already shown you. What can you say about these angles? What can you say about this angle here and this angle? These are also equal. Why? Because these are alternate interior angles, because this line is parallel to this line by construction and this is a transversal. Okay, so these two angles are equal. What can you say about the third angle? Third angle will definitely be equal. Otherwise you can show it by this angle, beta will be equal to this angle. Third angle, if two angles of two triangles are equal, then third angle will automatically be equal. Otherwise you can show by showing that AC is transversal and these two lines are parallel. This line and this line are parallel and AC is transversal. So these are also alternate interior angles. Now you notice these two triangles here. These two triangles are congruent by angle side angle congruency criteria. So I can say by angle side angle congruence rule or criterion, I can say triangle ADE is congruent to, when I say ADE, which angles I am talking about? Beta, alpha, theta. So I'll go beta, alpha, theta, CFE. So I have seen the correspondence now. Now I can say by CPCT. What is CPCT? That corresponding parts of congruent triangles are equal, right? So by CPCT, what can I say about these sides? Side AE and from here side EC. Side AE will be equal to side EC by CPCT, and this is what we want to prove here, right? So what can you say about this theorem? That a line drawn through midpoint of one side of a triangle parallel to another side bisects the third side, right? So this is what I have shown here.